Question 11 from Section 2 of the 2019 National 5 Physics Examination of the SQA. A student carries out an experiment to investigate the effect of different shaped glass blocks on the path of a ray of light. Part A. The student directs a ray of red light at a triangular glass block as shown in the diagram. Now for 2 marks in part I, it says complete the diagram above to show the path of the ray of red light through and out of the glass block. And for part 2 it says for 1 mark, state the name given to the line which is PQ. Well, the line PQ we know is going to be called the normal line. That's a very famous line when we're using ray optics. So that's going to be called the normal. And the normal is always at right angles to the glass face, or the medium's face. It's always positioned at right angles, and therefore that helps us decide where the ray of light is going to go, as we'll see in a minute. So we'll take the diagram out like that and go back to question 11a part I. There's our diagram we have to draw in. The ray of light is coming in to the glass face, and that's the normal P and Q. Now where does the ray of light go? It bends towards the normal. When it enters a medium from air into glass, it will bend towards the normal. So we take a ruler and we show that it's going to bend towards the normal, and we just draw in that line like that. So we take a pen and we have a line like that drawn in, and that's a ray inside the blocks. We can take a ruler away from us now. So the ray of light inside is going to go from here down into here, bending towards the normal. Now how does it come out the triangular block? It comes out the triangular block by bending away from the normal. It does the exact opposite. Now we have to draw our normal in first, so we have to go to the glass face, put a protractor or a set square with 90 degrees, and you can see the 90 degree line is there, 90 degrees. So we draw in our normal, and that's our normal drawn in like that. So we then can take away our protractor and we have our normal. Now remember, when the ray of light goes from glass into air, it's going to bend away from a normal. So we take our ruler and we position the ruler such that it's going to bend away from a normal. See the ray of light there, and it's going to bend away from a normal like that. So we take a pen and we just simply draw the line as shown like that, and there's the ray of light coming back out the glass triangle. So let's recap that. The dashed line, dotted line sorry, is the normal. The normal is at right angles to the face of the block. The ray of light comes in, and when it goes into the glass block, it bends towards the normal here. When it comes out the glass block, it bends away from its normal, and we get this path as shown. Part 3 says on the diagram above, label an angle of incidence I. Well, the angle of incidence is always going to be between the ray of light and the normal. So that angle in here is going to be angle I. That's going to be an angle of incidence. The angle of incidence is the angle between the normal and the ray of light which enters into the glass triangle. We can actually show this happening live. We go to that very, very important website, the SPHET website. You can see our ray of light here, our triangle. There's a little laser here, and we can switch the laser on and you can see that the path is identical. But we can describe it better by showing the normals what's going on. Here's the normals there, and you can see at the first normal the ray of light is going to bend towards it, but when it leaves the block it's going to bend away from it, and that's the path the red light takes as it goes through the triangular prism or the triangular glass block. Question 11 part B. The student replaces the triangular glass block with a rectangular block made of the same material. The path of the ray of red light is shown below. Now state whether the wavelength of the red light in this block is less than, same as, or greater than the wavelength of the red light in the triangular glass block in part A. And we must justify our answer. Well, let's go back to the PHET site, and you can see we've replaced our triangular block with a rectangular one. We'll switch on the red light And as you can see, the red light passes all the way straight through the block, mainly because it's going along the normal lines here. But as you can see, the red light is the same inside the block as it was with the triangular block. If I can just move that out of the way like that and put in the triangular block, there it is there, you can see we've got the same colour of red light. And the simple answer for that is quite simple, is that even though you've changed the shape of the block, you haven't changed the material of the block. It's the same material, which means it's the same optical material, which means it's got the same refractive index for that red light. So therefore the wavelength is not going to change inside the block.